Hi, this is Mahesh. I am chemistry lecturer. Today I am explaining about basics of organic chemistry. Here, organic chemistry means the study of carbon compounds. Is called as organic chemistry. The first synthesized organic compound is urea. In laboratory, the scientist Oler prepared first time the compound urea by the heating compound ammonium cyanide. So this is the ammonium cyanide. By heating this compound, we will get the compound that is NH2, CONH2. This is the urea. Urea is the first synthesized organic compound in laboratory by the scientist Oler. Here, carbon can forms a large number of compounds because of its unique properties. What are those unique properties of carbon means? Carbon can exhibit 4 unique properties. In that, first one is its tetravalency, and the second one is catenation capacity, and the third one is it can form multiple bonds, and it can exhibit due to isomerism. So these are the 4 unique properties exhibited by the carbon. So first come to the tetravalency. Here carbon can exhibit valency 4. So that valency is called as tetravalency. Here carbon atomic number is 6, and electronic configuration is 1s2, 2s2, 2p2. Here in the s orbital 2 electrons are there. In p orbital 2 electrons, and this is ground state configuration of carbon. In excited state, one of the electron excited to p level from s level. Then here s is having 1 electron, and in p orbitals 1 electron. Each are having 1 electron, and this is the first excited state configuration of carbon. In this first excited state, carbon has 4 unpaired electrons. So that's why carbon valency is 4, and that's why this is called as tetravalency. So carbon can form maximum 4 bonds. So this is the tetravalency. Next come to the catenation capacity. Here what is catenation means? Atoms of same element join together and forms a longest chains and branched chains and branched ring structures is called as catenation. Here atoms of carbon same join together and forms like this longest chains, and these carbon atoms join together and forms branched structures like this, and these carbon atoms join together and forms like this ring structures. So this is about the catenation capacity. Here carbon can exhibit carbon is having the highest catenation property in whole periodic table, and other elements are also having, and other elements also can exhibit this catenation property, that is nitrogen as M3, and oxygen also can exhibit as O3, and phosphorus also can exhibit as P4, and sulfur also can exhibit as S8. Here phosphorus comes to the phosphorus. This is the structure crown ring structure. And this is but these elements can exhibit in a small extent, but in whole periodic table, the carbon can exhibit this catenation capacity is higher than all the elements. Next one is formation of multiple bonds. Multiple bonds. Here, carbon can form 4 single bonds around it, like this. And the example for this is the formation of CH4. Here around the carbon in the CH4 having 4 single bonds. And carbon can form a double bond, like this. An example for this is C2H4. So this is a double bond. Next, third one is a carbon can form triple bond, that is like this. An example for this is ethine. So this is ethine, and this is ethene, and this is methane. And this methane is called as marsh gas, and this is also called as natural gas, and this is also called as biogas, and this is also called as fire down. So these are the different names for methane. And this is the ethine, and this ethylene is also called as ethylene. And this ethylene powder is nowadays used as for artificial ripening of fruits. And ethine, the mixture of this ethine means it is also called as acetylene. So the mixture of acetylene and oxygen is called as oxyacetylene flame. Oxyacetylene flame, and this can produce very high temperature up to 2800 degrees centigrade. So that's why this high temperature of can be used in welding purpose. So this oxyacetylene flame can be used as a welding purpose to join the various metals. And this is about the formation of multiple bonds by the carbon atom. Next one is isomerism. So what is isomerism means? Compounds which are having same molecular formula but which can exhibit different properties are called as isomers, and this phenomenon is called as isomerism. For example, consider here two compounds, that is CH3OCH3, and one more compound is CH3CH2OH. So its name is dimethyl ether, and it is the compound ethyl alcohol. Ethyl alcohol. So in this dimethyl ether, the functional group is present, that is ether functional group, this one. And in the second compound, in this ethyl alcohol, the functional group is present, that is OH. So this functional group is alcohol functional group, and this functional group is ether functional group. Now come to the formula of these two compounds. The molecular formula of first compound is 2 carbons are there, C2, and 6 hydrogens are there, H6, and 1 oxygen, O. And the formula for second molecular formula of this one is 2 carbons are there, C2, and 6 hydrogens are there, 6 and 1 oxygen. In both the cases, the molecular formula is same. Molecular formula is same, but this these two compounds can express different properties. Why? Because this first compound is having ether functional group and second compound is having alcohol functional group. The ether compound properties are different than alcohol compound properties. So like that, two compounds are having same formula, but their properties are different. Like these two compounds are called as isomers, and this phenomenon is called as isomerism. So these are the unique properties of carbon. So if you want to become perfect in organic chemistry, we should know about some fundamentals. In that, first one is we need to identify the nature of bonding between the carbon atoms and the type of hybridization of each carbon atom. Why? Because here carbon can form, already we know that, here the carbon can form large number of compounds. So that's why the type of carbon also we need to identify, and as well as the type of hybridization of each carbon we need to identify. Now look here, come to the types of carbon atoms. Types of carbon atoms. Look here, C bond C. Here, this carbon is bonded with another one carbon atom, and this carbon is bonded with another this one carbon atom. That's why this carbon is 1 degree carbon, and this carbon also is 1 degree carbon atom, or primary carbon atoms. So these are called as primary carbon atoms. Now, this is the first condition. Next condition is, this is the compound once observed here. Here, this middle carbon is bonded with two carbon atoms, this side and this side. So that's why this is a secondary carbon atom, and this is primary. Why? Because this carbon is bonded with this one carbon atom, and this carbon is bonded with this one carbon atom. That's why it is primary. And this is secondary, 2 degree. So this is secondary carbon atom of 2 degree carbon atom. Next, third one is this one. Here, this carbon is bonded with another one carbon atom, like this. That's why this is a 1 degree. And this is also bonded with another one carbon atom. That's why it is 1 degree. And this is also 1 degree. And but this middle carbon atom is bonded with other 3 carbon atoms. Here, here, here. That's why this is a 3 degree, and this is called as tertiary carbon atom. So next one is, now look here, this is 1 degree, this is 1 degree, this is 1 degree, this is 1 degree, but this is 4 degree, and this is called as quaternary carbon atoms. So that's why we need to identify the type of carbon atom in a given compound. So for some examples, some exercise, if we can do here, those are, so first exercise, identify nature of carbon atoms in this. And the second one is, so identify the nature of carbon atoms in this, and identify the nature of carbon atoms in this. So these are the some examples. And the fourth exercise. So this one. If you can go to the first example, here this carbon is bonded with another one carbon atom. That's why it is primary. It is secondary. It is secondary. It is secondary. Secondary. This is primary. Like that. Here this is tertiary. This is also tertiary. And this is also 3 degree. And this is also 3 degree. This is 2 degree. And finally, here this is 1 degree, but this is 4 degree. And this is also 4 degree. Here 1 degree, this is 2 degree. So the remaining carbon atoms, we need to identify that carbon is which type. So this is the identification of the type of carbon atoms. Very, very important fundamental property of carbon. Next one is type of hybridization. Type of hybridization. Type of hybridization. Here, between the carbon atom, all single bonds is there means that is the carbon hybridization is sp3. If between the carbon atoms, if any double bond is there, means that carbon hybridization is sp2. And between the carbon atoms, triple bond is there means then that carbon hybridization is sp. And between the carbon atoms, like this, where this middle carbon is having double bond and this is a double bond. That's why it is a sp hybridized carbon. And this is sp2. Why? Because only one double bond. Here also this carbon is having only one double bond. That's why hybridization of this carbon is also sp2. So these are the conditions to identify the type of hybridization of a carbon. If we can go through the number of examples, then one more example. So now here this carbon is having all single bonds, so that's why sp3. So now here this is sp3, this is also sp3, like that, and this is sp2, and this is sp2, and this is sp2, this is sp2, and this is sp, and this is sp. So in this way, identify the hybridization of other carbon atoms. So these are the some small exercises to identify the type of hybridization of a carbon in different compounds. Next one is nomenclature. Here nomenclature is two types. Common nomenclature and the second one is IUPAC nomenclature. Here IUPAC means International Union of Pure Applied Chemistry. So this nomenclature is accepted by in this IUPAC nomenclature is accepted for each and every compound. So now on the first one, common nomenclature. Common nomenclature. What is common nomenclature means? The nomenclature given to the compound based on source and nature of a compound and place of a compound. Then that nomenclature is called as common nomenclature. For example, come to the examples. First one, CH4 is called as marsh gas. Why? Because it is available in marshy places, in drainage places. So that's why it is called as marsh gas. And second one is HCOH. This is called as formic acid. Why? Because in Latin formic means red ant. hands. So here red hands can produce formic acid. That's why this acid is called as formic acid. Next one is CH3COOH. This is called as acetic acid. Why? Because in Latin acetum means vinegar. So this acid is present in a vinegar. That's why hence it is called as acetic acid. Next one is CH3CH2COOH. So this acid is called as propanoic acid. Why? Because prop means first. So it is the first prepared fatty acid. That's why it is called as propanoic acid. And this is called as butyric acid. Butyric acid. So why? Because butyrum means butter. So this acid is present in a butter. That's why this is called as butyric acid. Next one is this acid is called as valeric acid. Why? Because this acid is extracted from valerian plant roots. Hence it is called as valeric acid. So these are some of the examples for common nomenclature. But this common nomenclature makes a confusion to each and every compound. So that's why we should follow a systematic nomenclature. That systematic nomenclature is IUPAC nomenclature, and it is applied for each and every compound. IUPAC nomenclature. So here, what is the order to follow to write the name of the compound according to IUPAC means that order is first we should write prefix, and after that we should write root word, and next primary suffix plus secondary suffix. So this is the order we need to follow to write the name of a compound for each and every carbon compound. Here, what is now on to the first one, root word. What is root word means? This root word tells us about the number of carbon atoms present in a largest chain. So, for example, one carbon atom is there means the root word is with. Two carbon atom is there means the root word is it. If three carbon atom is there means prop. If four carbon atom is there means but. If five carbon atom is there means pent. If six is there means hex. If seven is there means hep. If eight is there means op. Nine means non. 10 means deck. And 11 means undeck. 12 means dodeck. 13 means trideck. Like that. C20 means ecos. And C30 means tricon. And C40 means tetracon. And C100 means heck. So these are the root words for number of carbon atoms present in a longest chain. If one carbon atom is there means the root word we should write with. If two carbon atoms are there means it. For three carbon atoms means prop. Like that, the number of carbon atoms having one root word. Next to come to the next one is primary suffix. Primary suffix. This primary suffix tells us about nature of bonding between the carbon atoms. If between the carbon atoms single bonds is there, means that in that time the primary suffix is A. Between the carbon atoms, double bond is there means in. Between the carbon atoms, triple bond is there means I. So these are the primary suffix for single bond, double bond and triple bond. So for example, if two double bonds is there means we should write di-ene. If three double bonds is there means we should write tri-ene. And if two triple bonds is there means we should write di-ine. If three triple bonds is there means we should write tri-ine. So these are the